My name is Antonia Harris, and this is my PowerPoint on endocrinology for my anatomy class at Grand Canyon University. So the two hormones that I chose to talk about are aldosterone, which is a lipophilic hormone, and cortisol, which is a glucocorticoid. And these are just examples of what hormones kind of look like. It's not actually aldosterone or cortisol. So the first one is aldosterone. So it is produced and released by the adrenal cortex or adrenal gland. And the adrenal gland is triangular and contains the that is the adrenal cortex. It has three layers, which is the outermost layer, the zona glomerulosa, zona fasciculata, and the zona reticularis, which is the innermost layer. So the main function for aldosterone is regulating electrolyte and water balance of the blood plasma, regulating the blood volume and our blood pressure, and lastly, it acts on the kidneys. And when it acts on the kidneys, it promotes the calcium retention, potassium excretion, and water retention indirectly. Next is cortisol, and like I said, cortisol is a glucocorticoid, and it is produced and released also in the adrenal cortex in the zona fasciculata. It is the most abundant and potent hormone or glucocorticoid. And the main function of cortisol is to ensure and maintain the blood glucose levels. Ensure and maintain the blood glucose levels between meals. So it also stimulates the liver in gluconeogenesis, and this leads to the glucose synthesis from the non-carbohydrate sources. It inhibits cellular uptake of glucose in most cells, which ensures enough glucose we're getting enough glucose to our brain, basically. It also contributes to the stimulation of protein degradation in the skeletal muscle and the bones, which releases the amino acids that drive glucogenesis. And it stimulates lipolysis, which is the breakdown of fats. And when it does this, that means it breaks down glycerol for glycolysis and free fatty acids to beta oxidation to generate ATP. It also has a permissive effect on catecholamines, which during that time it increases the binding affinity of epinephrine and norepinephrine to the receptors, and it promotes vasoconstriction, which with vasoconstriction that contributes to our blood pressure. Oh, and this is just the structure of cortisol. And if I go back, this is also the structure of aldosterone as well. I didn't talk about that. I thought that would just be kind of interesting, so I went ahead and put that in there. Yeah. And so this is just my reference. Of course, I use the book. I got all my information out of the book. And yeah, that's that.